Hello, everyone. So, Pascal, are you here on the line?
Hello, do you hear me? I think so.
Yes. Yes, we can hear you, Laurent. I'm just waiting for my co-chair to jump in, as he will be sharing the slides, and we'll get started. And just for yes, Pascal is coming. Eric, just one short question. I remember from the last time that MeTecho was connected to the Jabber service.
Hello.
Is it still the case?
Hello, Eric.
Yes, indeed. And you don't need to take any blue sheet. It's automated.
See Alex, but he will
Yes.
be doing the introduction, I guess. That's how we decided it. So,
Yes.
Alex, we don't have much time, so I suggest we don't wait for the usual extra hour if you want to start doing the introduction.
Sure. So, do you want to? Are you going to be? Okay. Let's get the screen share. So I'm just waiting for the slides to arrive.
I should be projecting the slides.
So
can you see them?
Yes, we are seeing. Yes, we are seeing the aggregate slides PPTX. So it's good. It's not in full screen, but I mean it's okay.
Yeah, I will place it full screen. I'm just not clear because I have a single screen. What you're gonna get if now I can control if I go full screen. Okay, I have a single screen, so even if I start a presentation mode, or maybe I can. Okay, let me check this.
Yes, so oh, perfect. It is perfect.
Okay.
Yes, it is full screen.
I shared PowerPoint before I went full screen, and then it kept on the other window, so I just stopped and restarted. Okay.
Okay. So, hello everyone. This is the working group meeting of the Lpwan working group, and today with you you have your chairs, Pascal Thubert and me, and our AD Eric Vinke, who is always with us in our multiple interim meetings. So I'm very happy that there are many new, many people that we've seen for the first time in the working group since a couple of times. So we start, of course, with the Note well. So this is an IETF meeting, and as such, all the IETF policies apply. So this means that by participating in the IETF, you agree to follow the IETF processes and policies. And if you are, so all the policies that, of course, apply for IPR, for good behavior, code of conduct, copyright, patents, interpretation, all of that, the BCPs, you should read them. So Note is just like a pointer. Yes, just a short reminder. So minutes are taken. This meeting is recorded, and your presence is logged. So the minutes are taken. I'd like to take time just to thank our official scribes, Laurent Toutin, Dominique Bartel, and Carles Gomez, who will be taking the minutes. But please join the CodeMD and do take the notes with them, because it's not all the weight should be falling on them. And I hand the word to you, Pascal.
Okay, and I'm copying the link to the CodeMD on the chat, and since I'm full screen after that, I won't be able to see the chat, so I will let you monitor that, Alex, and if somebody wants to speak, please stop me. Okay. So yeah, I just shared the CodeMD link, which is there. As Alex said, we have Laurent taking the minutes for us. And yes, we already uploaded the meeting material on the Lpwan session. So if you want to follow it from the agenda, the IETF agenda, you will find it. Agenda for today. So we'll start with Alexander presenting the Lp1 architecture, which is a new draft, but that still needs quite some work, and we hope we'll have time soon to improve it. But at least you have an FT presentation here from Alex. Then Laurent will tell us about the progress on the Yang data model for SHIC. Then Juan Carlos will present us new ideas actually on how SHIC can be used over Sigfox. Then Anna will have a little time to tell us the latest and greatest news about the progress of the co-op static context, for which Anna and Eric, we have to thank you so much. Then I will have a few minutes to present you the SHIC of our PPP work, which is actually happening at the Interia working group and not here. And then AOB if anything else needs to be discussed. So between last IETF and now, we had a number of interims, and we actually updated our milestones and agreed with Eric that we would push the SHIC of our Sigfox to fall this year and NB-IoT work to early next year. So that's pretty much the main changes. So the work now should concentrate on Yang and then on the OAM document, which has been started. The news, so there are a number of good news. Let me show you if you see my red circles. First good news is, and Anna, you will have your 5 minutes, but I'm so delighted that I need to announce it now. So yes, co-op static context header compression is now in the RFC editor queue. It's been sitting there for only 2 days, but soon the editors will start editing it. And the other very, very good news is the SHIC of our LoRaWAN document is already being processed by the RFC editor. I wrote here the states for you to interpret this, but edit is awaiting edition, or edition has started, but really in this case, probably awaiting edition. And the RFC editor state means really well advanced and being reviewed by the RFC editor team. So we're getting there with the SHIC of our LoRaWAN document. And then, as you can see in the other circle, there is the Yang data model document for which we actually pushed a review request to the Yang doctors. So that's why you see this review statement about the Yang doctors. And so, as you can see, there are 2 documents which are sitting there and waiting for adoption. The very new Lp1 architecture that Alexander has mostly edited for now, and Dominic's OAM document, which would deserve some more new work as soon as you can. Dominic, you're welcome to show us what's happening there. And with this, Alexander, I will leave you the presentation. And please let me know.
Yes, thank you, Pascal. Yes, please. So, yes, everyone, this is, of course, we've been waiting for a couple of years now, but right now we've had a couple of major milestones that we closed, and we're opening a new fields that, you know, in this architecture work really shows, and the goal is to show how all these bits and pieces work together. So we wanted, the first thing to do is to just do a short recap of you know what the LP1s are and how we are aiming at them. So we actually took some slides that we used from the very first BOP that we had. So low power wide area networks. So click Pascal. Or can I? Yes. So low power, these are things that are designed to be working many years, 20 years on simple battery. So I click wide area. I cannot click. Next slide, please. So wide area, it's you know, able to communicate over very long distances. And next slide. here is actually the really interesting part. Star topology, huge densities, and we have case where the communication is device initiated with strongly asymmetric links, where the uplinks are much cheaper than the downlinks, and the throughput is very, very, very low, right? And all that combined, and on the next slide, please. All that combined, we can have operation in license-free or in license spectrum, and there we have a bunch of other questions, how to handle about, duties like cycling collisions and the modes of operation. So basically, what we've done in this working group until now is really to focus on all these different, and the next slide, please, on all these different constraints and different considerations. Next slide. Maybe it's not proceeding for me. Next slide, Pascal.
So I'm moving the slides.
Slide
if you're not
14.
seeing them, maybe someone else is. And so I was on slide 16, the one which says RFC 83676 Lpwan architecture. That's what you're supposed to see.
Okay, thank you. So yes, I'm in a quite a okay. I'm page 16. Okay, it's getting a little bit slower to me. I think it's blocked, but it's the connection on my side. It's not terrible. So basically, this is the architecture where we have the overview of network. So that's you can find in all types of Lpwan networks. So on the left-hand side, we have devices that communicate over the radio communication in the long distance to the radio gateways. Then the radio gateways are connected to an element that is called the network gateway that does the interconnection between the radio and the application behind, and that also does the authentication of the devices and this part of the security. So next slide, please. That will be 17. Yes, so this is where we also took this huge opportunity to actually be working with the four major Lpwan technologies, and we did this. That's really one of the first major RF documents that combines all these technologies, RFC 8376, and I'd really like to thank the authors of that draft, that it's really showing, they took really the time to align the terminology, and we decided, we need to have the IETF terminology. So we have in this table, like the device in the IETF and the corresponding to terminology in LoRaWAN and the different different technologies. So that's the overview of the work done until now. What the SCHC architecture document is doing is providing a reference architecture of how the different systems are working together. So until now, we have identified two modes of operation. The first one is in the classical SCHC device and SCHC gateway mode, where we have the device and the gateway working together, and we also identified a mode that we can call the SCHC peer mode, where we have peers, SCHC peer devices or SCHC peer gateways talking to each other. So the architecture also, shows, and the goal is to show how the data model is used and how the device and how the rules are created and updated and how they're installed and discovered. Next slide, please. 19. Yes. So what we have is, of course, the end device that needs to talk to the network application. Next slide. The network application is residing on an application server. Next slide. So we have the radio gateways that are around the device. Then we have the network gateway that it's connecting to these radio gateways. And then what we have is like the full view with the element that we call here the SCHC gateway. So we have the SCHC device and the SCHC gateway so that corresponds to the full architecture of how the system is working. Next slide. Yes. So and we have IP communication, like IP UDP COA, but it can be any network protocol communication between the SCHC device and the application. Next slide, please. Now, when we zoom in the SHIC gateway, we have identified that there are like three functional blocks there. We have the rule manager, the rules, and the SHIC compression, compressor, decompressor, and fragmenter, recombiner, like on all that the functions, right? And the device is basically communicating with the SHIC, with the rule manager, or with a protocol such as CoreConf. And the rule manager is managing actually the rules. Next slide, please. So we can basically do a zoom in the SHIC device as well. And here what we can have is like a full SHIC device and a full SHIC gateway communicating to each other. So both of them will have the SHIC compressor, decompressor, and fragmenter recombiner. Both of them have the rules, and both of them have rule managers. And the rule managers are talking to each other over a protocol, such as CoreConf. And the data representation, so the way the rules are represented, is by following the Yang data model. Right. So that's when we're talking about the SHIC device and the SHIC gateway. And the same thing goes for SHIC peer mode of operation. So these are actually quite metric, and we think that in most cases these will be there will be a lot of overlapping functionality. It's just that, you know, we'd like to keep for the moment this separation because the SHIC device and SHIC gateway, I mean, there is this notion that, you know, the SHIC device is much less powerful than the SHIC gateway, for example, whereas in SHIC peer mode of operation that could be between two gateways, and both can be really full-fledged. And so here we have this operation where, yes. So what we have here is an example of that operation where we are talking on the network level SHIC. So that SHIC can operate on the network level. It can operate on the application level, as with the co-op over SHIC. And so here what we have is like this expansion of, let's say, of two SHIC peers over SHIC device and SHIC gateway. And we have the applications talking to the IP stack. And we have how actually the rule managers are communicating. Next slide, please. How actually the rule managers can be communicating, you know, so through CoreConf OS core, but they can actually be communicating through the IP stack, through the IP stack, and going through the SHIC compressor, decompressor, and fragmenter recombiner. And so the two rule managers are communicating to each other. The rule manager, one of the rule managers can on the other end, they can push to other place to fetch the parts of the rules, and so really there are the building blocks of this architecture allows the operation, you know, start from the bootstrap to discovery to, you know, the operation of two SHIC enabled things, if you wish, SHIC device, SHIC gateway, or SHIC peers. So that's, oh, really sorry to hear that. So that's the end of the presentation.
Okay, Alex, thanks so much. You are breaking up a little bit, but I hope that people could actually hear. Yeah. So as Eric says on the chat as well, yes, the audio was not perfect, but on my side, I could get most of what you were saying. I mean, don't worry too much. And then the next speaker will be Laurent about the Yang data model. So do you wish to share your screen, or do you want me to move the slides, Laurent?
No, you are doing it very well. So
I'm the best page turner of the world. Go ahead.
Okay, so I will present the version 4 of the Yang data model. So can you go back to this one? So there is no more difference between the 3 and the 4. We have now a model that is quite stable. So the only difference is some clarification in the text. So I remind that the goal of this document is to define the value that we find in SHIC on RFC 8724. And there is two functions. One is to define identifier that we will use in the SHIC rules, and to define the structure of this rule, either for fragmentation and compression. So we, as I say, there is a strong link now with the architecture draft. And here is just the definition of the young data model. So we don't look at how to implement it, and all these things will be done next using, for instance, CoreConf. So on the next slide, please. Next one. So here is a way we define identifier. So first we define, for example, here is for the RCS algorithm. So we define an identity based, and then we derive all the algorithm that we can find using this identity reference. And from that, we defined a type def that will be used on the structures. So next slide. So here is all the IDs that you find in the draft or in the young model. So we have things for identity type. So it's all the field that we will compress. So it's cover IPv6, UDP, COAP, underscore. So these are things that are in RFCs or in future RFC. There is also ICMPv6 from the AOM draft that is still at the draft level right now. We have the field length type that can be either a length or a function that can be var or token length. We have the direction indicator, up, down, or bidirectional. We have all the 4 matching operators, the 8 compression, decompression action, and that's for the compression. And for the fragmentation, we have the RCS algorithm, as we saw in the example. And right now, we have only one single value. We have the fragmentation mode. We have some parameter also for icon error. Next slide, please. So here is an example. Chic. So I saw Chic is okay. I don't. So here we have the identity. So here is an example. Next slide. And here is another example, including co-op options and all that stuff. So it can look long, and of course we cannot send that on a compressed on a constrained network. So we will have to use CoreConf, for example, to have a value instead of this long ASCII string. Okay, next slide. For the structure, so the structure are quite common to what we see in the RFC. So we have a rule. So a rule is a Chic set of rules, is a list of rules. Each rule is identified by a rule ID and a rule length. And then we associate to these keys either a fragmentation rule or a compression rule that we will see after. So for the fragmentation rule, we have a part that defines the Chic header. So the Chic header will start with dtag, a window size, and a dtag, a window, and a FCN. And here we indicate the size of these fields. We have the RCS algorithm, and then we have parameters that are used by the state machine and that are defined in the annex of 8724. And for icon error, can you go back? And for icon error, we have also some operation mode tied in all one or ACK behavior that can be defined. For the compression, next slide. So compression rule is a list of entry. An entry is identified by a field ID, a field position, and a direction ID indicator. And here you will, and after that, you have the list of all the fields that you find in ASCII table in RFC 8724. So one discussion maybe we can have, it's about the field length. Dominic raised that maybe this field can be optional. I agree. So we will have a question mark here to say that it's not mandatory to fill it, but it will be present in the model because we see some usage for it. Next slide. So right now we have a quite stable draft. We have discussed it in several interim meetings. We have also some informal meetings with some offer. and Dominic made a very nice review of the document. So now I think we can go forward and be ready for a working group last call, or ask for a working group last call.
Okay, merci. Thank you very much, Laurent. Before the work group last call, I guess we want to see the result of the young doctors. Did you get any news, Eric, on the young doctors review?
I was basically about to ask Laura whether we got some private replies. On my side, I got nothing back. So maybe we need to circle back over email on this, because
Okay.
I think it's important for going to the last call.
So Laurent, no news, right? To answer Eric.
Sorry?
As Eric asked you, you didn't get anybody contacting you
No, I
personally.
didn't get any contact. I have to check again my mail, because if it's personal mail, maybe I have missed it, but not sure.
Okay. Okay, so let's do a round offline. Okay,
So-
thank
so
you very
just-
much,
just-
Laurent.
Just one point on the working group last call. So I mean, we have the document for quite some time, and I get the feeling, and I did a couple of reviews. I probably need to do one last public review, but it seems to me that the document is quite. I mean, it's finished in many aspects. So launching a working group last call seems like a good idea, in the sense that then of course we'll need to put in copy netnode probably, and you know, that will put people also in the sense that, hey, well, you know, we consider the work done, and you know, if there are any reviews, now is the time to do them. So
there are basically two things in a document like this, right? There is do you have all the content? And for that, there is nothing better than an implementation. We have a number of implementations, so we can actually check the content, and the content was written based on those implementations, so we're pretty safe there. And the second thing is, I would say, the youngness of the document. I mean, is it the way that, you know, the young experts would express the things that we have in the code, and otherwise, I mean, yes, I mean, there's nothing opposes the work group last call. I really would like to see the young doctors come up to us, so we can review the final format for the work group last call. But like you, I'm happy with the document as is. If it was not for the young doctors, I would be launching the work group last call. Okay, it's you have 2 more minutes than scheduled, Juan Carlos. So the ball is yours. Do you want to share your presentation, or should I push the slides as I did so far?
If you can push the slides, Pascal,
Okay.
probably it's great, so that we can keep going. So thank you very much, everyone. Juan Carlos Zúñiga here, and presenting an update on the SHIC over Sigfox, as well as the 5SHIC hard code. So we've been working again on the offline coding with help from University of Chile and University of Catalonia for the ACON error and NOAC parameter optimizations. We this time were focusing on error conditions that have been tested. For the last updates, we added a long list of message sequence examples that explain the different ACON error and NOAC and SHIC error scenarios that we've been testing. And very importantly, we have also updated the co-authors list because of the strong contributions from this work. We have now welcomed Sergio, Diego, and Sandra onto the authors list. So thank you very much for the help. And out of that, in fact, we have also been working on compound SHIC-ACK message proposal with the intent to save on the protocol overhead number of acknowledgement messages on different situations, but still keeping the flexibility of the NOAC mode where we can send opportunistic acts over a session. So for this, we are going to show some slides, and I'm going to pass it on to Sergio right now.
Hello, my name is Sergio Aguilar. I'm from UPC, and I will be presenting to you the proposal regarding the compound ACK message. In ACON error over Sigfox, when check fragment losses are present in intermediate windows, at least one ACK is generated. When the check fragment losses are presented in the last window, at least two ACKs may be generated. And independently on the check ACK size, the Sigfox downlink payload size is fixed to 64 bits. Therefore, when errors occurs over multiple windows, the number of ACKs can be reduced by reporting losses of several windows in a single ACK. Here we have an example of a 14 tiles check packet with a window size of 7 tiles and errors over multiple windows. In this case, we have 3 ACK messages. Can we go to next slide, please? The compound ACK principles are, in this case, it only includes or it only reports windows with check fragment losses. For each bitmap, the window number must be included. It may not fit all bitmaps of all windows for a check packet. It has a variable size and is compatible with the check receiver abort message format and the ACK failure message format. And the advantages of the compound ACK is the ACK reduction. In this case, the ACK reduction is related to the number of regular check fragments minus the number of windows minus 1. In this case, as the number of windows of a check packet increases, also the ACK reduction will increase. Can we go to next slide, please? Here we can see the proposal of the ACK message format. The ACK header is fixed and is the same as in the RFC 8724. After the first bitmap, you may add as many window number plus bitmap groups as windows with losses. In this case, you can add as many as you can fit on the downlink payload size. In this case, we can see the example of the compound ACK of the 14 tiles check packet transmission we saw before. Can we go to the next slide, please? Other details about the compound ACK is that the window number plus bitmap groups are ordered from the smallest window to the largest. And if the window number 0 has error, in this case is present in the ACK, it must always be between the rule ID and the CBIT to avoid confusion with the 0 padding bits. In this case, we included this example that is of a 14 tiles check packet because it was more clear. There is also in the presentation another example of a 28 check packet size with also error distributed in all windows where you can see also the ACK reduction and while using the compound ACK message format. Next slide, please. Thank you very much for your time. Any questions or comments?
Yeah, Dominic.
Hello, can you hear me?
Yes.
Yes.
Good. Nice work. Congratulations. I was wondering, you just mentioned that you avoided confusion with padding bits, and you said 0 bits. Does that mean that you mandate in the Sigfox profile that padding bits are 0, or is it?
Actually, is in the ACK, if I'm not mistaken, in the RFC, in the 8724, the negative ACK format has padding bits of 0.
Well,
so it's still using the same format regarding the padding bits.
8724 has padding bits, and it recommends that padding bits are 0, but it does not mandate that padding is 0s. That's up to a profile. So I was just curious if you have defined in the profile that the padding bits are 0, and then you're safe. I'm not saying it's broken. I'm just asking.
I'm not sure, but we have been using as the other
Right.
other RFC the 0 padding.
just make sure it's written that padding bits must be zeros, otherwise your distinction may not work.
Okay.
And also, are you
Thanks for
using bitmap compression when you do this aggregation, or is that
Actually, we thought about bitmap compression, but in the downlink payload size of Sigfox is fixed to 64 bits. We have extra room for using. We don't need the compression. That's the thing. So we are not using bitmap compression.
right? And it's probably safer that it's not data dependent, otherwise you might be exceeding the payload size. Okay, got it.
Right. Yeah. Indeed, Dominique. Just to add that this makes it more predictive because we know exactly how many bitmaps we can always fit, and also because they can be discontiguous. This gives us some clarity on the format, adding the window bits in the beginning of the bitmap.
Right, got it. Thank you.
We'll add that if the window is higher than 7 bits, then you can detect it among the padding.
Sorry, could you repeat the question? No.
That if the padding can be 7 bits long, no more, not more. So if you have a window, what you call the W here, is more than 7 bits, then it will be detected.
Yes, in this case, I'm not sure, but we are using padding until the 40. In this example, we use 42 bits padding to fit the 64 frame of Sigfox.
Right. So the proposal here is what we're saying is we are trying to comply as much as possible to the RFC 8742, but then we believe that there's a lot of gains by using this format. So we are proposing then to add this format definition in the draft.
I mean, I don't see why you could not. I mean, you can always inherit from an RFC and add additional methods. So if you want, if that's what you want to do, and if it's the best for your case, I mean, just do it.
Okay.
It's just a new message format, so you can always propose a new format.
Right.
So yes, the only thing the group can do is just what Laurent and basically what was just done is try to see if there is a bug hidden in there. But
no, I think the question is more: do we generalize this to other protocols, or if we keep it to Sigfox, there is no problem, because here we know that the downlink is at a fixed size, and so you can do tricks on bit values, but can be generalized to something else.
Okay.
as presented, it looks very, very opportunistic to the Sigfox case. So I don't see that we need to define it elsewhere. And if another RFC wants to know, I don't know, NB-IoT, but it won't need this. But if another RFC in the future needs this, it can always take inspiration, but probably they will. They will tune it slightly differently. So I would not make too great efforts to try to generalize it. It's a great opportunistic technique for the case of Sigfox, and certainly I encourage. But let's leave it at that for now. And
how about it? I mean, so actually, I think that's an excellent question. What if some other technologies would be?
So you cut Alex, but I think hearing the inputs here, maybe what we can do from our side is to make sure that we document correctly the principles, the advantages, and then the applicability to Sigfox, so that if ever other technologies want to inherit or point to the same principles and advantages, they can do so without necessarily going to the specifics of Sigfox. Okay.
Yes, they will probably redefine
yes,
something for
yes.
themselves, which would be very could inherit from this, but might be slightly different. It's really opportunistic. I mean, just the fact that the hack has so many bits that you can really fit more than one window in there. I guess it's matches Sigfox. And the fact that you don't want done links and you want to compress them into one message. I mean, all this is Sigfox, but it's nice. I mean, you re-optimize. That's why we wanted to have those technology drafts, right? To optimize for each given case. But how do we know that the next case will need exactly that or would do its own slight variation? So now it's, as you said, you make it public, you explain how it works. And if ever another technology needs something like that, similar, but maybe their own version of it, they will define it as well. I'm very happy with this. Spending time on trying to generalize this now it looks like overkill to me.
Okay. Dominique?
Yeah, I would just recommend, sorry I didn't have time to read the new version of the draft on this, but I would just recommend that you make it very explicit how an implementation can distinguish between the regular hack message and the new one, and what are the criteria. And of course, it's probably simpler than in the general case of 8724 because you have a byte alignment. And we spend quite a lot of time describing all this, how ambiguity is avoided. So I'm just hoping this will be the same level of description in this draft. Thank you.
Yes, thanks. By the way, just to add on that, thanks for the input. And we wanted to first show the concept and get feedback. So we have not documented in the latest version of the draft yet this proposal. We wanted to first hear the feedback. So our plans are now to take all this comments and information, feedback, etc., that you have given us to make a new version of the drafting and then include the details. But yeah, Dominique, to you, we have added some slides on our presentation to explain as much as possible the concept. That's where you will find information. But otherwise, you can expect some more details in the next version of the draft.
So Dominique, do you still have those slides that you presented when you explained the working of SHIC, and you explained exactly those? Because if you could dig those slides and send them to Juan Carlos, maybe Juan Carlos could build some similar slides using similar formats, and then we could merge all this in our tutorials.
Okay, I'll try and do that. I'm not sure I had slides. We had slides every so often on the new improvements, but I think the content went actually in the text of the RFC. But yeah, I'll see what I have as a material that could be a starting point.
Because to understand exactly the games of those zeros and ambiguity and avoiding ambiguity, that's one of the most tricky things in SHIC, this zero hack. So having slides which explain exactly how it works, that's very useful. I thought you presented something like that at one IETF, but okay.
Okay, I'll look it up. No worries.
Okay, so but that would be nice to just extend that with, okay, here is the difference for Sigfox.
Thank you very much.
Here's how it works, and have a single story that we can review, because reviewing is a bit hard in this case. Okay, so actually it's pretty much time for this slot. We can take one more question. Well, I guess that's it. Thank you so much for this presentation. I really love when we have a technical discussion like this during an IETF meeting as opposed to just going through slides. So yes, please, let's build those slides for an interim where we explain exactly how we do the ambiguity, how we resolve the ambiguity today, and how that is done in Sigfox, and make sure there is no room for any ambiguity. Okay. So next will be Anna. You have 5 minutes, Anna, on the co-op static.
Thank you.
You want me to move the slides?
Yes, please. So, hello, everybody. I'm happy to announce that we have successfully sent this draft to the RFC editor queue. we received the last comments from Benjamin just before the IETF, and we work with Eric to post the last version this Monday. So now we are done. Is going to the editor. So congratulations to everybody that has give input to this work. For my next slide, I would like to explain more quickly the changes between version 16 and version 19, how this has been moved from over the versions, because it has been done very quickly. So in version 16, we have rewritten section 2 with the use cases and keeping all the same terminology. Section 6 with the co-op extensions to explain better how to compress them. Section 4, we put a new introduction for the new header options, if in case there were a new option created for co-op. So this is a new part. And then we send it for revision. In version 17 and 18, I put it together because there's not so much differences, because when I published version 17, I saw that I forgot a comment from Benjamin, so I published version 18 with this new comment. But the big difference is the section of co-op options for variable length fields and the security section again. And the last, not the least, but as soon as Benjamin verifies the version 18, he accepted and he gave us a present. He gave us a security section for this draft. So I want to thank you very much to Benjamin Kaduk for this valuable input. So there are many editorial needs and you can verify them. Next steps, of course, we wish that we get 9024, because this will give us the same number of chick 24. So we will see.
I guess we can ask for something like this, Eric, if we contact the RFC editor in due time, unless they've already attributed this number.
You can indeed. Send me a reminder. I don't think you can. You may. I may, and I think it's a nice idea. So Anna, please send me an email. I will do my best.
Okay, thank you.
And then you owe me some chocolates, right?
Yeah, we will see. Thank you very much, Eric.
I mean, that doesn't make sense, Eric, because the best chocolates are from Belgium anyway. So
yeah. So if there are some questions, something else.
no, so just like I said, it's in edit state, meaning that the RFC editor has not yet put his hand on this, but it's only been there for 2 days. So
yes, that's it. We send it on Monday, so
yes, and also pressure that we push out.
Oh, you're breaking up, Alex.
But yes,
sorry, I don't understand.
Congrats to people first. Congrats.
If you write it in the chat, perhaps we can read it.
Or if you use reliable and available wireless.
Or something else. Nothing important. Congrats. Yeah.
Okay.
Thank you.
So we will move on to the next slide. We are pretty much in time. So thank you so much, Anna, again. And let me now do the final presentation. So this is actually a document which is being followed at the Interior Working Group, but for which we really need help from the Lpwan working group, because it's dealing with Shake and how to use Shake for at least some part, and it's not the expertise that we can expect from Interia, and we really expect that expertise to be coming from this group. So I will keep keeping the group aware of everything that happens on this document. So for now, it's SHIC over PPP, but as you know, we did it because once you have PPP, you have foo, because PPP was initially designed for serial lines, but then there is PPPoE for how you do PPP over point-to-point Ethernet, even across the switch fabric. And then once you have Ethernet, you have Wi-Fi. So you can basically apply SHIC to a number of technologies as soon as you do SHIC over PPP. As Alexander mentioned in the architecture document, typically the model for SHIC over PPP would be a symmetrical peer-to-peer model. So we'll discuss that. What we do in this draft is we signal in existing PPP signaling a new compression. There is already a way in PPP to signal which compression you're going to use. You can use von Jacobson, for instance. Here we're going to use SHIC. So we just added in an enum a new compression, and I guess the value was 2, meaning SHIC. Now, when you signal the compression in an option of PPP, when you set up the core, you can also signal some parameter. And the only parameter that we signal here is actually a URL where we expect that the data model, based on the Yang document that Laurent has just explained, would be located. So the idea here is, compared to the normal old version where you ship a SHIC device with hard-coded rules that may even always use the compressed format and never really operate in the uncompressed format. Here the model is both sides operate on IP, and they both fetch the rules from a same place. So they are kind of, as Alexander said, they're kind of both gateways. And so they both get the compression from that place. I expect that the compression is symmetrical, so it's not like there is a device side and a gateway side. That would be symmetrical, and they will basically apply the rules that they fetch from the same place, which is the way we ensure that we get matching state in the compression and the decompression. So for this, effectively, we have a dependency on the SHIC document. So I just placed here the shape of a packet as it would be if the document is implemented as is right now. So you can see that the rule ID occupies the first 2 bytes after the PPP protocol signaling IPv6. And so the compressed piece, what we call the residue, occupies something, and the alignment is in the draft is done at some to align to 1 byte at the end of the compression residue. But the expectation is that there will be some content in the packet which will not be compressed. So we have this extra thing that does not appear in SHIC with the uncompressed payload from the original. So we expect to compress up to some place, do the padding there, and then add some more bytes all the way to the end of the packet. So it's not exactly matching what you may expect from the SHIC document, but the question is it against the rule or is it acceptable? And it's back to the same discussion as Sigfox, right? If that's how we do it in this environment, well, worst case is we can say that this document updates at 8724. But I'm still not clear if it's legal with 8724 not to do it this way. So the document is pretty old. I need to refresh it by the end of this month. So the other rules, I don't have much time, so I won't go through the details. They were presented at the interim. Basically, that's we now have compression for the rules, and we do have fragmentation. And the reason for doing fragmentation is if you want to use a deterministic network which operates really, really fast, and you want to be able to schedule it, what you want to do is bring every frame down to a small and same size, so you can reschedule independently of what the packet is. And so for this, SHIC could be a very, very useful tool, because you would say, hey, let me align everything to 64 or 128 bytes. And you would compress every frame, which is bigger than that, down to that. So yes, as Alexander presented, this creates a pairwise relationship in the architecture as opposed to device gateway. There is not any of the endpoints which owns the compression rule, which is what I was saying. And we guarantee that they have the same state, because both will fetch it from the same place. And that's pretty much it. I don't have much time to go through this flow. The real question for today is, first thing, I'm a bit alone on this one. Is there somebody who's willing to work with me on this? So feel free to raise hands now or contact me on email. There was the question of the applicability statement. All I've been saying here is actually not written in the document. I expect that the architecture will cover a lot of it, but do we need to say, hey, here is why you would do fragmentation, here is why you would do compression, blah, here is why it's useful? And do we want some text on that?
I think it's important to have it, because it's, for example, when you put the padding in the middle, it means that it's not so efficient with fragmentation. So I think that in PPP, you don't expect a SHIC fragmentation. So, are you here? I lost you. Pascal?
So Pascal is he's still connected, I'm not sure. And also there was Eric in the queue. Eric, would you like to?
Muted. I got muted. I'm back.
Oh.
Can you hear me? Hello?
Eric?
Yes, we hear you, Pascal.
Okay. So I don't know how long I've been muted. Laurent, when you talked, you were
Yes,
hearing
I was talking in your eyes and you disappear when I finish my question.
Oh, I didn't do anything. Okay. So I was asking, so for the applicability statement, and you said yes. And I was wondering if there is anything else that you would like to see in this document. Oh, basically, I also answered you, maybe to nobody, that this is an option to have some uncompressed data at the end of the packet. Now, if you want to fragment, probably you would not be doing this, but it's an additional capability that I have if you're not doing compression. So yes, maybe we can explain that, Laurent. That would be a good thing to explain. But you don't have to put uncompressed data after the padding. You may do so.
So I think it's better to explain how you use it. It's, for example, it could be to interact, to interconnect some SHIC gateways, but I don't think it's the case. So it's more for real-time systems.
Yeah, I can give you examples that I have in mind, and I've not applied SHIC yet to those environments. But for instance, in the smart grid infrastructure, there's a protocol called Goose. And if you're aware of Goose, it's a very, very chatty protocol where you have to expand very long names. So before the frame says anything, it transmits a lot of bytes to just give always the same very long ASCII string names. And what I wanted to do in this case was to be able to compress all those Goose headers, which give you those long names and blah, and provide the Goose data in the uncompressed way. Just compress all these very, very long headers that they have, and not fragment actually in that case. So that's an example that I had in mind. I did not write about it. I did not even do the exercise of applying SHIC to Goose, but it seems to me that it makes a lot of sense from what I understand of how Goose works. So that's why I have this kind of example.
So sorry to
perfectly.
interrupt you,
Yes, go ahead, Eric.
Pascal. Just want to enforce and second your comment about this working group following the discussion on the inter-area working group. You know that subscribing to a mailing list is easy, and the inter-area is on Friday. So please go review and have Pascal as a co-author on this draft. That's very important.
Okay, so I guess we're getting out of time for this meeting.
Yes.
So if you think about extensions, if you want to contribute with me on this draft, if you have ideas about the applicability statement and things that I may have missed about where it can work, where it cannot work, and everything is welcome on the mailing list. Please come back to me on anything like that. And with this, we are getting to the end of this meeting. So we have just a minute or two if there is any AOB.
I don't think so. So thank you all. Thank you for one very interesting session and a very interesting couple of months since the last IETF, and looking forward for the next interim. And excellent work, everyone. Thank you, Pascal. Thanks, Eric.
And congrats to the authors of the SCHIC Co-op and the SCHIC over LoRaWAN. That's great achievements that we did here. Okay, so meeting is adjourned. Thank you so much for being here today.
Thank you. Bye-bye.
Bye-bye.
Bye.